Bit shift right instruction.
Bit shift right. The second of the bit shift instructions. We did the bit shift left, and this is the logic that you should have at this point in your lab projects. You can see I've removed some of the toolbars and moved them out of the way or eliminated them to give us more vertical space so I could geezer up the logic here any larger than that. And well, if we do that, we lose our clear down here, which is fine. So I'm going to go ahead and geezer up one more time and pull this over. Okay, with a bit shift right, instead of seeing the bits shift, now it's to the right on the screen, but it's to the left in the bit array. That's why I pointed out emphatically early on that it's not your left and right, it's from least significant to most significant, or most significant to least significant. Since this is the bit shift right and it's a length of 6, then instead of the source bit values coming into bit 0 and shifting to 5, then out and bit 6, instead we're loading the source bit into bit 5, and then it's shifting this direction to bit 0. So just for grins, I'm going to move the source bit down here between 5 and 6. And in the lab manual, I had you try the source bit to see that it works, then turn it on and leave it on. With the source bit in the on state, which it is, toggle the bit shift right enable bit, which is local 1i data 2, on and back off once. Push button on, off. And you can see that this value shifted into the first bit in the length of 6, shifting to the right over to bit 0. Remember, for the bit shift right, it's most significant of these 6 bits towards the least significant as it shifts. Has nothing to do with your left or right. Ignoring the source bit, how many additional, if any, bits changed state? Be careful with your answer. Some things appear in more than one place. Well, there were 2 bits that changed state. Obviously, element 1 bit 5 changed state, and local slot 1 output data bit 1 also changed state because it's showing the last array bit is on. That would be similar to the first array bit when we were shifting in the other direction. Trick question: did you see any bits shift? Well, I would say no, you didn't see any shift. If you want to say yes, you saw it shift from the source bit to bit 5, that's okay. As long as you understand completely what the bits are doing, how you interpret the questions and answer the questions is entirely up to you. My goal is that you understand the behavior of every single bit in this array of 3 double integers, the unload bits, etc. That's what I'm after. Okay, change the source bit fill device back to the off state. So we'll flip that off, toggle the enable bit for the bit shift right once. You see it goes to bit 4. Ignoring the source bit, how many bits change state? Well, I say 3. Bit 5 went off, bit 4 went on, and local 1 O data 1 went off. Remember, that was on down here. Did you see any bits shift? I would say no, you don't actually see them shift because you just see something go off and something go on. And positionally, because we created a little kind of HMI here, you could see it go from here to here. So if you answered yes, then I would say it shifted from 5 to 4 to 3 to 2 to 1 to 0, and then to the unload. Because remember, this is the unload position. So that 0 that was here shifted to the right unload down here. Then 1 went into 2, 2 into 1, 3 into 2, 4 into 3, 5 into 4, and nothing into 5. Toggle the enable bit on and back off once. Leave it off. Ignoring the source bit, how many bits change state? Well, I'm saying 2. Bit 4 and bit 3. This went off and that went on. So those 2 bits change state. Did you see any bit shift? Well, I put no as a graphical user interface type question. But if you put yes, then it would have been that they shifted from 5 out. So the unload came from 0 and the source bit went into 5, 5 to 4, and so forth. Well, actually, 0, bit 0 went to the unload bit. Then 1 to 0, 2 to 1, 3 to 2, 4 to 3, 5 to 4, and then the source bit into 5. Repeat the momentary on state until you've got the single on state down to the last element. So we want to shift it down to bit 0. That's actually the last position. Now it says first array bit here, but I was not about to rename these bits to match the direction between these 2 bit shift instructions. So you realize this is one end and that's the other end. Bit 0 and bit 5 are the ends of our shifted array, if you want to call it that. Did the single on bit shift across rung 0 to the first position? Yes, it did. Did the bit unload? Well, that on bit did not unload because it won't do that until the next shift. But the zeros did unload. So again, you could answer that question no or yes. Your choice. No, that on bit that's now in bit 0 did not unload. Or yes, the 0 that was in those other positions unloaded into the unload bit every single time you did a shift. Repeat the momentary on state of the enable tag one more time and stop. Is the first bit in the shift register still on? No. When I say the first bit, I meant this bit. When I said still on, this was on before, now it's not. So the answer is no. Is the unload bit on? Yes, it is. Is the bit prior to the first bit of the defined length on or off? Well, that would be this bit right here. This is the first bit prior to that position. No, it did not go on. The question really was asking, this was 1, a value of 1. We shifted, it unloaded it, but it did not go from the lowest bit, least significant bit, in element 1 to the most significant in element 0. Then I had you open up the display of your program tags and expand it out and ask you if yours looked like this. And of course, if you have all zeros, then yes, it did. Set the source bit switch to the on state. We'll go back to logic. Source bit is on. And repeatedly enable the bit shift right until you see the on bit come to the first bit of any array 1, then stop. So that would be there. Now we didn't unload, but we have both ends of it turned on. That's why those 2 lights are on. And then turn the source bit switch back off and enable the BSR until you see the values in the illustration to the right. So let's go back to our data table. You see on the left in your manual it shows 63. That's all of these binary positions add up. They add up to 63. Then we're going to do a bit shift right until we see a 1 here. One more. See, we have a 1 and a 2, which is a decimal 3. Shift it one more time. Now they match. How many on bits are left? Be careful not to count the value of the entire dent. You don't have 2 on bits there. That's the value of the whole dent. Right there's the bit. We have 1 bit left. 1 on bit state left, and that's any array element 1 bit 0. While watching that bit, enable the BSR one more time to see what happens when it leaves here. One more time. It just goes off into bit space. Is the unload bit on or off? Well, it's on because we just shifted this bit, unloaded it into this position. Did the first bit of any array 1, that is bit 0, shift to the right into the last bit of any array 0, bit 31? No, it did not. What are the boundaries for the state changes affected by the BSR instruction? Well, we're totally in any array element 1, so it would be any array element 1, bit 0 through bit 31. Execute the BSR once more. Did a 0 unload. So before we do that, remember this is the last position when you're shifting to the right. So whatever here goes to the unload. So I'm going to shift it. Now you see there's a 0 there. You can say it went off, so the off state got moved to this unload position. Set all of your dents to a value of 0. To do that, you would go to your tags here. The easiest way to do it. See, they're all zeros. Go back to our logic, and then I had you toggle from the keyboard this bit on here. Now I'm going to move this back down here because that's the way it was in your lab manual. What I want to show you next is there is a value of 1 poised here. So we're going to do a BSR, and you might think that this 1 is going to go into this position. But remember, the source bit is off. And when we do a bit shift, we shift 0 to the unload, 1 to 0, 2 to 1, 3 to 2, 4 to 3, 5 to 4, but we don't shift 6 to 5. We shift the source bit value into 5. Just to prove that, I'll go one more BSR 3. See, it disappeared. That BSR, bit shift right, it loaded a 0 into there, even though in a sense, you think it shifted in, and it did, in a sense, shift here, but then it was immediately overwritten by the value of the source bit. Did the execution of the BSR entrain the value just past the most significant? This is the most significant position of our 6-bit array. This is the just past the most significant. Did that value get entrained into this position? I would say that the answer was no, because the end result was that whatever the value of the source bit was, that's what got loaded into bit 5.